Hi, we're starting Chapter 6, Section 4, which is all about graphing y equals ax squared plus bx plus c. The title's a little bit deceiving because we're not really going to be doing tons of graphing, at least not in the notes. Figure you probably could punch the numbers into your graphing calculator if you wanted to, then you could use trace or the table function. You got that covered. But what we're looking more is at like a height equation that relates to that and converting from one form to another. So first I want to start out just kind of by defining the forms. And in 6.3 we talked about this vertex form. And the vertex form equation is y minus k equals a parentheses x minus h parentheses squared. So then this tells us, hey look, we have a parabola because we have an x value that's squared, and h and k are going to be the vertex point, and a tells us if it opens up or down. Going back to an earlier section, we talked about standard form. Standard form for a parabola is going to be y equals ax squared. You always list the x values with the highest exponent first, and then plus bx, or plus some number of x to the first power, and then plus c, some number without any x values to it. So the first thing is converting from vertex to standard form, or from this top line to the bottom. And I found if I really just give people one bit of advice, most people are able to get it correctly. The mistake is that when we have this x minus h that's squared, people forget to FOIL it. They just take the 2 and say, alright, I have x squared and then an h squared. That never works. I talked about it in the notes from section 1. Please, please, please don't do that. So Roman numeral 1, converting from vertex to standard form, expand the binomial first. In my example, let me quick copy this down, is y minus 4 equals negative 2, trying to be a little tricky, putting a negative in there. Then I have an x minus 5 quantity squared. For some people, they just can look at this x minus 5 quantity squared and write out the trinomial. If that's you, by all means go for it. But I'm going to write it out in smaller steps just so I don't lose any of you people having a math party at home right now. And this x minus 5 quantity squared is really x minus 5 times itself, or times x minus 5. And now that we have a binomial times a binomial, we'd have to FOIL those. Some people like distributing the 2 into this first set of parentheses, and then having negative 2x plus 10, and then that being times x minus 5, and then FOILing. Personally, I like just taking care of the FOILing here. So we have our x squared when we do the first ones. Then outside is going to be a minus 5x. Inside is another minus 5x. And then negative 5 times negative 5 when we do the last is plus 25. That's pretty ugly. Let's make that a little better. So plus 25. So that's what we get when we FOIL. And whenever you FOIL, you're able to combine the outside and inside terms. I'm going to keep writing this down. I found a lot of people forget this minus 4. So I'm going to make a point of writing all the steps. And so then I have an x squared minus 10x, which comes from combining these two here, plus 25. Okay, so my binomial squared became my perfect square trinomial. And now I can go through and say, hey look, I need to do negative 2 times each of these 3 clumps in my trinomial. So I'd have negative 2 times a 1x squared for minus 2x squared. Negative 2 times a negative 10 gives me a plus 20x. And then negative 2 times a positive 25 is minus 50. Like I said, some people stop right there. But if you take and copy down that left side, you'll see you're not quite done yet. We're not in the y equals something. So then we have to go and add 4 to both sides. And I'll extend my page a little bit there. I'm left with y equals negative 2x squared plus 20x. Because the 4 didn't have any x's with it, it has to be combined with this minus 50. So it's going to be a minus 46. So that's really kind of the first half of the notes, is just being able to go from vertex form down to standard form. And that's a guaranteed question you're going to see in the book, on quizzes, on tests. It's a skill that you really just have to know in this class and going on to pre-calc. The next part is going to be the height equation for an object in free fall. And I'm a little biased because I teach physics. This is totally a physics thing. But it fits because we're talking about parabolas. So this is one of the equations you should have memorized for the test. So h equals, it's really looking at what's the height of an object going to be after a certain amount of time's gone by. This would be true if you drop an object, if you throw an object up, if you throw an object down. It's going to be this here. So we'll say h equals negative 1/2, then gt squared. This clump here tells you what's the height going to be just from gravity. Then it's also going to be impacted by, did you throw it up, did you throw it down? So we have this plus v sub naught. The little zero just tells us this is the initial velocity times time. And this little section says where would the object be if there was no gravity, just based on you throwing it. And then we also have to figure out, well, where are you starting? Are you starting at the ground? Are you starting on top of a building? So then plus h sub naught, or h with a 0. Just saying this here is the initial height, and that's the other. Okay, I should write out a little bit what these things are. So I'm going to say this is true where, we'll just go left to right. H equals the height after t seconds. G is going to be acceleration due to gravity. And you really have two options, and that depends on your units that you're using. So you have to look at the problem and find out, are they talking about meters, as velocity in meters per second, or is it in feet per second? Or is the initial height, is it in meters or is it in feet? Your two numbers are going to be either 9.8, and that's if you're doing meters for your units for distance. So 9.8 meters per second squared, or 32, and that's the number you use if they're talking feet for the distance, and feet per second for the velocity. But it would be 32 feet per second squared. Those are just two numbers that would be good to memorize. T is going to be time, so T equals time, and I'll maybe put in seconds, because if our G values are meters per second squared or feet per second squared, you have to be time in seconds. V sub naught, or V with a little 0 in the subscript, is the initial, that's the 0 part, initial velocity, that's the V. And the last thing then is this H sub naught, which is the initial height. And again, you could look at the initial velocity and initial height to figure out what the units are going to be, what you have to use for G. Alright then, our last example for this section says write an equation for this. You're waiting on the top of school. I'm guessing that's about 9.5 meters. And you're going to throw a water balloon down with a speed of 4.2 meters per second at me when I walk out the back door. Write an equation for the height of the balloon as a function of time. You could write out the whole story problem. You could just say like 9.5 meters up, throwing down 4.2 meters per second. That's really all you need in the thing. But so I'm going to start just by writing out that equation. And as I've said so many times before, it'll help you memorize it, so you don't need to cram it the night before the test. It's going to be worth some points, and it's going to be on there. But h equals negative 1/2 gt squared plus v sub naught times t plus h sub naught. I should make a comment. Sometimes I've put on a test before, that somebody drops the ball, thinking, hey, I'm making it easier for people. And then I get people making all kinds of crazy things up for this middle section. Well, if you're just dropping the ball, your initial velocity is 0. And 0 times any amount of time is going to end up being 0. So this middle part, you just kind of drop out. You can ignore it. In this point, though, we're throwing it down, so that's not going to work. Okay, so we have 9.5 meters. So that tells us then in this first part, we have negative 1/2 times g, which is going to be 9.8. I'm going to just leave units out of it. Gross mistreatment of science, but I'll pick up the units in science class. If you want to simplify this to just say negative 4.9 t squared, that's actually a better answer. But I'm going to write it negative 1/2 times 9.8 times t squared. Feel free to do it that way as well. Plus, I started writing the plus, but really I shouldn't. If you think about it, when you throw something up, That's going to be adding to the height. So I'm going to jump back up here and say initial velocity. Maybe we'll say that if this is up, it's positive, because it's going to be adding to the h values. If you're throwing something down, it's going to drop. The h is going to get smaller faster. So then down is going to be a negative. So then really becomes plus a negative velocity, or simplified just to say minus. My initial velocity is 4.2. And again, I made it minus 4.2 because it's a downward, times t, plus my initial height of 9.5. And that'd be the height equation you could use. The only thing you might want to do to change that is you could, like I said before, write this as negative 4.9 t squared minus 4.2 times t plus 9.5. I like making my t's with kind of a little curve on them. Helps because there's way too many t's and pluses in this equation. But that is really all that there is in section 4.